Hey everyone, and welcome back to our channel. Today we're diving into one of the biggest questions humanity has ever asked. Just how big is the universe? Get ready, because the answer is truly mind-bending. Let's start with what we can actually see. This is called the observable universe. Imagine a giant sphere with Earth right at the center. The edge of this sphere represents the farthest we can possibly see. Now, you might think that since the universe is about 13.8 billion years old, this sphere would have a radius of 13.8 billion light-years. That makes sense, right? Light from the most distant objects has been traveling for 13.8 billion years to reach us. But here's the twist. The universe has been expanding the entire time that light has been traveling. Think of it like this. Imagine two people walking away from each other on a rubber sheet that is also being stretched. By the time one person's voice reaches the other, the distance between them is much greater than just the distance the sound traveled. The space itself has stretched. Because of this cosmic expansion, the actual diameter of the observable universe isn't 27.6 billion light-years, but a staggering 93 billion light-years across. That's 93 followed by 9 zeros in light-years. And a single light-year is already about 9.5 trillion kilometers. The scale is just immense. So, we know the observable universe is about 93 billion light-years in diameter. But what about the age? How did we figure that out? Scientists have determined the age of the universe to be approximately 13.8 billion years. This number comes from carefully measuring the rate at which the universe is expanding and then running the clock backward until everything was crunched into a single, incredibly hot and dense point. This initial moment is what we call the Big Bang. It wasn't an explosion in space, but rather an explosion of space. Everything we see today, every star, every galaxy, every planet, originated from that single point 13.8 billion years ago. Now let's talk more about this expansion. It's one of the most fundamental concepts in modern cosmology. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. He observed that almost all galaxies are moving away from us, and the farther away a galaxy is, the faster it's moving away. This isn't because we're at some special center of the universe. Instead, it's the very fabric of space-time itself that is expanding. A good analogy is baking raisin bread. As the dough rises, all the raisins move farther apart from each other. No single raisin is the center of the expansion. Every raisin sees the others moving away. In our universe, the galaxies are the raisins, and the expanding dough is space-time. The rate of this expansion is described by the Hubble constant. Measuring this constant precisely is one of the biggest challenges in cosmology, and different methods have given slightly different results, leading to a bit of a scientific debate. But the core idea remains: the universe is getting bigger every second. This expansion is what stretched the light from the early universe, allowing the observable part to grow to its current 93 billion light-year diameter. This brings us to a truly mind-boggling question. What's beyond the observable universe? The simple and perhaps frustrating answer is, we don't know for sure. The edge of the observable universe isn't a physical wall. It's just a horizon, a limit to what we can see. So, what could be out there? There are several fascinating theories. One of the most straightforward is that the universe just keeps going. It might be vastly larger than what we can see, potentially hundreds of billions of times larger, or it could even be infinite. If the universe is infinite, then somewhere out there, beyond our horizon, there are infinite copies of you, me, and everything we know, arranged in every possible configuration. It's a concept that's almost too strange to comprehend, but it's a genuine scientific possibility. Another idea is the multiverse theory. Our universe, with its specific laws of physics, might just be one bubble in a vast cosmic foam of other universes. Each of these other universes could have completely different physical laws, different dimensions, and different histories. While this is highly speculative, it's an exciting area of theoretical physics that tries to answer why our universe has the properties it does. For now, all we can be certain of is what lies within our cosmic horizon. And what we've found so far is nothing short of spectacular. How many galaxies are in the observable universe? Early estimates based on the Hubble Space Telescope's deep field images suggested around 100 to 200 billion galaxies. That number is already hard to wrap your head around. But more recent studies and refined calculations have pushed that estimate up significantly. The current consensus is that there are likely around 2 trillion galaxies in the observable universe. Let me say that again. 2 trillion galaxies. And each of those galaxies is a sprawling city of stars, gas, and dust. Our own Milky Way galaxy, for example, contains somewhere between 100 and 400 billion stars. And many of those stars have planets orbiting them. If you multiply the number of galaxies by the average number of stars per galaxy, you get a number of stars that is simply astronomical. It's more stars than there are grains of sand on all the beaches of Earth combined. So, when you look up at the night sky, remember what you're really seeing. You're seeing a tiny, tiny fraction of our own galaxy. Beyond that lie trillions of other galaxies, each a universe of stars and planets in its own right, all drifting apart in an ever-expanding cosmos. The universe is not just big, it's bigger than we can possibly imagine. Its size, its age, and its sheer number of worlds challenge our perspective and remind us of the incredible, vast, and mysterious reality we are a part of. It's a humbling thought, but also an incredibly exciting one. The quest to understand it all is what drives science forward. Thank you so much for joining me on this cosmic journey today. If you found this as fascinating as I do, please hit that like button and don't forget to subscribe for more deep dives into the wonders of our universe. Let me know in the comments what cosmic question you'd like us to explore next. Until then, keep looking up. Hey everyone, and welcome back to the channel. Last time, we took a journey from our home planet Earth out to the edges of our solar system. We saw gas giants, icy worlds, and realized just how tiny we are in our own cosmic neighborhood. But that was just the beginning. Today we're zooming out even further to ask the question, just how big is big? Prepare to have your mind blown, because we're about to explore the true scale of the cosmos. First stop, our home galaxy, the Milky Way. Think about this. If our entire solar system, out to the farthest planet, Neptune, was the size of a single coin, the Milky Way would be the size of North America. It's a sprawling, spiral city of stars, stretching about 100,000 light-years from one end to the other. Inside, there are hundreds of billions of stars, possibly more than 400 billion. Each of those stars is a sun, and many of them likely have their own planets. The sheer number is staggering. It takes our sun, traveling at a blistering 828,000 kilometers per hour, about 230 million years, just to complete one single orbit around the galactic center. That's a galactic year. The last time our solar system was in this position, dinosaurs were just beginning to roam the Earth. Now, let's talk about that term. A light year. It sounds like a measure of time, but it's actually a measure of distance. It's the distance light, the fastest thing in the universe, travels in 1 year. Light zips along at about 300,000 kilometers per second. So, in 1 year, it covers a mind-boggling 9.46 trillion kilometers. When we say the Milky Way is 100,000 light-years across, it means if you could travel at the speed of light, it would still take you 100,000 years to cross it. Our nearest neighboring star, Proxima Centauri, is a little over 4 light-years away. The light we see from it tonight left that star more than 4 years ago. Looking at the stars is literally looking into the past. But here's where things get really wild. Our magnificent Milky Way? It's not alone. It's just one galaxy in a gravitationally bound group we call the local group, which contains over 50 other galaxies, including the famous Andromeda galaxy. Andromeda is our bigger sister, about 2.5 million light-years away, and on a collision course with us. Don't worry though, the big merger won't happen for another 4.5 billion years. So you can cancel your intergalactic moving plans for now. This local group of galaxies is itself just a small part of an even grander structure. Zoom out further, and you'll see that galaxies aren't scattered randomly through space. They clump together, forming vast clusters and even bigger superclusters. Our local group is on the outskirts of the Virgo supercluster, a colossal collection containing over 100 galaxy groups and clusters. The Virgo supercluster itself spans over 110 million light-years, and even that is just one small tendril in a much, much larger structure we call Laniakea, which means immeasurable heaven in Hawaiian. Laniakea contains about 100,000 galaxies and stretches more than 520 million light-years across. It's so immense that our entire Milky Way is just a tiny speck of dust within it. These superclusters are not just blobs. They form a breathtaking pattern. Imagine a gigantic, three-dimensional spider's web stretching across the universe. The long, glowing filaments are made of thousands of galaxies, and at the intersections of these filaments are the most massive galaxy clusters. In between these filaments are vast, dark, and mostly empty regions known as cosmic voids. This cosmic web is the largest known structure in the universe. It's the grand architecture of existence, a shimmering tapestry of light and gravity on a scale that almost defies human comprehension. The journey from one side of a large void to the other could take hundreds of millions of years, even at the speed of light. This brings us to a fundamental limit: the cosmic horizon. Since the universe had a beginning, the Big Bang, about 13.8 billion years ago, there's a maximum distance from which light has had time to reach us. We can't see anything beyond that point, because the light from those objects hasn't arrived yet. This boundary is our observable universe. Based on the expansion of space, the current diameter of the observable universe is estimated to be about 93 billion light-years. That's our cosmic fishbowl. It's unimaginably vast, containing at least 2 trillion galaxies, each with billions or trillions of stars. But what lies beyond that horizon? Is it just more of the same, more galaxies, more cosmic web, stretching on forever? Or is it something else entirely? This is where science moves into the realm of fascinating, mind-bending theory. One of the most popular ideas is the concept of a multiverse. This theory suggests that our universe might just be one bubble among an infinite number of other universe bubbles. Each of these universes could have started from its own Big Bang and could even have different fundamental laws of physics. In one universe, gravity might be weaker. In another, the speed of light might be different. Think of it like a massive cosmic foam, where each bubble is a separate universe, completely inaccessible and unobservable to the others. Our 93 billion light-year observable universe would be just an infinitesimal part of one single bubble in an endless sea of bubbles. While we have no direct evidence for the multiverse yet, some theories in physics, like string theory and cosmic inflation, naturally lead to this possibility. It's a humbling thought, isn't it? Our entire existence, everything we've ever known or will know, could be just one reality among a countless, perhaps infinite number of others. So, how big is the universe? The honest answer is, we don't know. We can measure our observable part, this 93 billion light-year sphere, but what lies beyond is a complete mystery. It could be infinitely large, or it could be finite, but just much, much larger than what we can see. The journey from our planet to the edge of what's knowable reveals a scale so immense that our human minds can barely grasp it. We've gone from a single planet to a solar system, to a galaxy of billions of stars, to a cosmic web of trillions of galaxies, to the theoretical edge of an infinite multiverse. It shows us that the more we learn, the more we realize how much more there is to discover. The universe is not just bigger than we imagine, it's bigger than we can imagine. Thank you so much for joining me on this incredible journey to the edge of reality. I hope it sparked your curiosity and left you with a sense of wonder. If you enjoyed this cosmic exploration, please hit that like button, and don't forget to subscribe and turn on notifications so you won't miss our next adventure. What topic should we explore next? Let me know in the comments below. Until next time, stay curious.